Okay, so now we're going to talk a little bit about Module 3, Lesson 5. This is on solving equations with fractions in them. We're going to look at some simple ones first. Let's look at something like this, and then we'll get a little more complicated later. So we're going to be solving equations, and the general approach is going to be very similar to what it was when we didn't have any fractions in our problems. We're going to be trying to get that y, that variable, on one side by itself. So to get rid of this minus 11 over 17, we're going to use the opposite operation. So we're just going to add 11 over 17 to both sides. And I'm just going to go ahead and solve this directly because my denominators are the same. When I have different denominators, we're going to use some different strategies a little later. But for this one, since all of my fractions are like, I'm just going to go ahead and do the algebra and solve for y this way. So that'll get that by itself. And then over here, because these fractions are like, this is straightforward. We're just going to add the top. So negative 7 plus 11, different signs. We're going to subtract them. Take the sign of the bigger one, and then we're going to keep the bottom number the same. Okay, so when my fractions are like this, I'm just going to go ahead and solve them directly. When I have some fractions that have different denominators, though, I'm going to take a slightly different approach. So let's look at an example there. So this will be our equation. Okay, so in this particular problem, we have some unlike fractions. So when we have some unlike fractions like this to work with, what we're going to do instead, we're not just going to start moving things and doing the algebra right away. What we're going to do instead is we're going to find our LCD for the entire problem. We're going to look at all of our denominators, find that lowest common denominator for all of them, and then we're going to use that LCD to just get rid of the fractions. We have some options now, since we're dealing with an equation, to just eliminate the fractions right away. So if I'm looking at this, looking at my denominators, I'm going to start with my biggest denominator, just like we did in the last lesson. Multiply it by stuff until I find something that all my other denominators will go into evenly. In this case, we don't have to go very far. 14 times 1 is 14. And 7 does go into 14. So 14 is my LCD. Okay, so what I'm going to do with that LCD is I'm going to take it and I'm going to multiply it times every single term in this problem. I have to do it here in the middle too. All of my terms, I'm going to multiply them by the LCD. And because of the way we found this LCD value, our denominators are all evenly going to divide into our numerators. Like here in this first term, 7 divided by 7 is 1. 14 divided by 7 is 2. Everything from the bottom is canceled, so we've just got 2 times 4, or 8, left there. Every single time, our fractions will be gone. In the middle, not much I can do there. Just bring that 14 and that y down. Over here, these 14s are just going to cancel. 14 divided by 14 is equal to 1, and so we've just got a negative 3 left there. You'll notice now that I've gone through, multiplied by my LCD, canceled all my fractions out, I've just got whole numbers left. I don't have any fractions left in the problem. This will happen every single time. Now, you probably will wind up getting fractions at the end. There's nothing you can do about that, but we can work it just like we would have in Module 2 now. We're just going to work towards getting that y by itself on one side, so I'm going to subtract 8 from both sides. Get rid of these. And then divide. And again, like I mentioned, the fractions will come back. But for the work, for the algebra, we didn't have any fractions to deal with. We do also want to make sure that we're keeping in mind that we do need to try to reduce these fractions to lowest terms. Again, this one doesn't reduce, but you want to make sure you're checking to see if you can break these down at all. Okay, so here's a similar problem to look at. We're going to solve for y, so we want to get the y by itself, but I have a bunch of unlike fractions here. So again, same approach as last time. I'm going to start by finding my lowest common denominator for this stuff. And again, same approach that we've used throughout. We're going to start with our 20, multiply it by values until we find something that all of our other denominators will go into evenly. Again, most of these are going to be pretty straightforward in this class. 20 times 1 is 20. 5 goes into 20 evenly. 4 goes into 20 evenly. So 20 is going to be my LCD. Okay, so next step is to take that LCD and multiply it times every single term. Okay, on both sides of the equation. So 5 goes into 20 4 times. 4 times 6 is 24. 4 goes into 25 times, so 5 times y. We'll just bring those down, and then the 20s over here will cancel, and all of my fractions are gone. This will happen every single time if you pick your LCD correctly. You'll wind up with a new equation, doesn't have any fractions in it. Okay, and so now it's just a matter of solving for y like we would have in Module 2. We'll move this 24 over. 24 minus 24 is equal to 0. 1 minus 24. Okay, and then we'll divide by -5. We know a negative divided by negative is a positive. And we've got it. So 23 over 5 is our answer there. You can change this into a mixed number if you want, but again, if the instructions don't specifically say mixed number, to me there's no benefit to that at all. This is easier to work with, and I would leave it in this form. Okay, so let's do one more here. We got a couple of just numbers on the left-hand side, so you can, if you want to, use the process we learned in lesson 4 to subtract those right away. But to me, because we have this equal sign, because this strategy that we're using today, it only works if we have an equation. We have to have this equal sign. And because we have this equal sign, I think it's just much easier to just get rid of the fractions right away. So I'm going to start by looking at all my fractions, finding the LCD for them, starting with my big value. It's a 20. 20 times 1 is 20. 5 goes into 20. 2 goes into 20. So 20 is my LCD. So then I'm going to take my 20 and I'm going to multiply it times every single term in this problem. Okay, and all of my fractions will go away. 5 goes into 24 times, so that's a 4 left there. 2 goes into 20 10 times, so 10 times 7 is 70. Over here, the 20s are gone. X is by itself, all of my fractions are gone. And the nice thing about this one is, because these are just numbers on the left, we're just going to subtract those. The X is already by itself, so we're in great shape and we're finished. Okay, so again, really nice when we have an equation like this. We have to have an equal sign for this to work, but just find that LCD, multiply through by that LCD, and all of our fractions are going to go away. We'll get an equation that doesn't have any fractions for us to use for our algebra process. Okay, so hopefully that's enough to get you all off to a decent start with this. Please let me know if you have any questions. Have a good day.